Okay, in this video, I want to take you through how to demonstrate photoelectric effects is. So photoelectric effect is. So photoelectric effects, as is written here, is the emission of electrons. So the emission of electrons from the surface of a metal or any charged object when electromagnetic radiation of appropriate frequency incidence on it. Okay, so that is basically what this phenomenon is about, photoelectric effect. So we want to look at how this phenomenon happen. How does it happen? But before then, let's look at this. Photoelectric effect is a phenomenon that proves that light is a particle or has a particle nature as well as the wave-like nature. So let's look at how photoelectric. Okay, so as electrons, when light of electrons, when light that is of appropriate frequency drawn here, this is the photocell. 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 We have the anode positively charged, we have the cathode negatively charged, and then we have the source of light coming in all the way from outside. So this can be a lamp or any source that can help us get a light or any radiation of appropriate frequency. This radiation incidence on a cathode here that is negatively charged, immediately electrons are emitted and they are directed or attracted onto the anode. When this thing happens, it closes the here we have the, so you can see that from here to here we have the battery, we have the emitter, but this circuit is not closed when electrons are not emitted. So when electrons are emitted immediately and carry the circuit and current begin to flow. So to determine that this effect is happening, you will see when that is ammeter over here will read. When the ammeter read, it means current is flowing through the device. That is photoelectric effect is okay. Echo here, that is evacuated tube. Echo here, that is evacuated tube. Echo here, that is evacuated tube. In this evacuated tube, we have the anode and we have the cathode. We need evacuated tube because we want to remove all air particles that will collide with the electrons, therefore slowing down the kinetic energy or the speed of the electron onto which is attracted onto the anode. Okay, secondly, we have to keep this place, or we have to keep the anode and the cathode in a evacuated tube, because if we don't do so, it will cause the surface of the cathode to be oxidized. Therefore, we have to evacuate all the air from this tube. And then you can see that the light is passing through the tube. That means this is a transparent glass tube that allow light or radiation to pass through it. And then you have the battery that makes this side negatively charged, that is the cathode. It makes here negatively charged and it makes here to positively charged. It makes here, so it creates a potential difference. So as soon as the electrons are emitted, it gets attracted onto the anode and it closes the circuit, and then the signs that photoelectric effect is happening. But we have to look at it. So for photoelectric to effect to happen, the frequency of the radiation of the photon must be appropriate. So the frequency over here must be appropriate. Okay, so this photon or the radiation has energy E equals hv, that is Planck's constant times the frequency. So as the frequency increases, the energy increases. But For us to get the total idea of photoelectric effect, we know that every electron is bounded onto the atom by the Coulombic force. So for one to remove an electron from the surface of a metal, certain work must be done, and in this phenomenon, it is called the work function. The work function, and is always denoted by W naught, and is always equal to the Planck's constant times the minimum frequency that the photon must possess in order to remove this electron. So in our next video, we will look at how we can do some um, calculate or solve problem involving photoelectric effect. So basically, that is how one can demonstrate photoelectric effects using Photocell. Thank you.